Hey guys, I'm back. Okay, so today we're going to work on Chapter 20. We're going to talk about MIG procedures, what to set it up, different types of transfer modes, and different types of discontinuities. So we might have to do part 1 and part 2 today, but we'll check and look and see what's going on, okay? All right, let's go. All right, we don't need objectives. So MIG wire. MIG is really kind of cool. MIG wire are a lot smaller in diameter than stick electrodes. This means because maybe a stick electrode on average is an 1/8 inch, okay? And it shows us kind of right here. Let's make this a little bigger so you guys can see. So it shows it that it's an 1/8 inch. On usual, we're going to use an 1/8 inch diameter rod at 100 amps, or we can use a GMAW rod or electrode at 0.035 diameter. So that's pretty tiny because we know that 1/8 inch into decimal is 0.125. So it's almost triple the size of this. Okay, this also means that I don't have to have such a wide root opening. Okay, and the thicknesses don't have to be as thick, or I don't have to make a bevel so fat because I can get in there. I can get in there a little bit better. That means I don't have to fill up or use so much material when I try to fill up a joint. Okay, really important, and this is a really good advantage of using MIG. Okay, now we want to make sure that we use the correct work angles and travel angles. Okay, so we were talking about work angles when we on the other basic knowledge video, and we were talking about the angles. So if we're using a horizontal, okay, we're trying to keep it at a 45 degrees when we're doing a T-joint, correct? Okay, so when we're going across at a 45 degrees, we can never do it a true 45 degrees because we kind of need to tilt it a little bit so we can see where we're going, okay? So this is our travel angle, okay? So we're going to give it a tilt. And when we run MIG, in order for us to get better penetration, we're going to drag it, okay? So we're going to drag the material, okay? If we're going to use a flat position, like in a groove well, I'm still going to use that 25 or 20 to 25 degree travel angle so I can see where I'm going. If I make my travel angle too steep, I'm going to lose all my gas. And then we have gas drift, and then we have other issues. So we have to pay attention. We can also affect the shape or contour of our bead by not only our angle, but our travel angle as well as our travel speed. All right, so I was just talking about pulling, okay? Pulling is going to give us more penetration. It's made for thicker materials. When we push, okay, that pushing is going to be for thinner or lighter gauge metals. That way we don't burn through them. All right, so welding conditions can change during welding. Well, here it is. What's a variable? A variable is a mathematical term that says this can change. So if I'm having problems in certain areas, this little table kind of gives me a hint. This is my cheat sheet here, okay? It says, well, what am I trying to make? I'm trying to make better penetration. So the thing is, make it hotter. Drag it, okay? Decrease your stick out and use a smaller wire with CO2. Oh, I don't want too much penetration. Decrease your current and use a push. Have a longer stick out and use a larger wire, and you might want argon and CO2. Okay. Now, if we're looking to change our height of our bead, we change our voltage, our travel angle. And if we're looking for a faster deposition rate, we increase or decrease our travel. Okay. This helps us get a better idea until we start getting really good at this to make those changes that are necessary. All right, so we want to make sure that we have good contact to our work, okay? Otherwise, we can have issues. We also want to make sure that we're in the habit of cleaning our material. That means at minimum, wire brushing. If my material is dirty, it's going to cause issues and discontinuities, okay? We also want to make sure that we have clean equipment. That means making sure that you guys clean the cup after every couple of passes, because otherwise it's going to block your gas flow. You're going to also want to make sure that your contact tip is clean. Otherwise it's going to impede your wire. All right. Okie dokie. So we're going to talk about different types of transfer. What do I mean by transfer? Well, there's different types of modes that GMAW can exist in. Okay. The most common is GMAW-S, and it stands for short circuit. So what really happens is that the wire is being fed out, and when it touches the surface of the metal, it actually completes the circuit and it pulls down a little piece of wire. And it does it really quickly and keeps going. That's why you hear zit, 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 zit. So if we look, it says the welding wire touches the weld pool, causing a short circuit. Okay. Now, the current builds up, causes the electromagnetic to have a pinch force, and pulls that droplet down. Okay. And then it transfers into the weld pool, and then it goes back and forth. And it keeps going. But we're looking at a lot of different cycles very, very quickly. Okay, now the next one is globular transfer. These are really big droplets that we call them globs. Okay, so these droplets are pretty much about 2 times the size of my electrode, and the way this works is that we're getting it hot, so it makes a glob at the end of my wire, and the arc and the shielding gas actually pull it down across the arc. The thing is, this really isn't a very good process because it's really irregular. It spatters all over the place, and you can't get really good deep penetration. Not only that, it really doesn't work out of horizontal position. Okay, it's just kind of gooey and nasty and gross. All right, spray transfer. So pretty much what's happening is instead of having big drops, now we have little teeny tiny drops that are either the size of the wire or even smaller, and it's coming down quote unquote in a spray. So the wire is getting hot and it's breaking off these little pieces, and then the arc and the shielding gas are help bringing it down into a spray. Okay, this is much hotter, and this is mostly preferred for aluminum. Okay, all right, now we have what's called pulsed spray transfer, GMAW-P. Now, this uses spray transfer, but we're using it in a different way. It's kind of going on and off. So really what happens is that let's say we have a welding current of 100 amps. Okay, that's going to be our background. And we want it to peak out at 200 amps. Okay, so the bottom is going to be always at 100 amps. And then for every couple of seconds, we're going to say we want it at 200 amps. So it's going to go, and it's almost like making and pulsing a bunch of spot welds. Zut, 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 zut. When we have a peak and a background current, it allows the metal to cool off. This means like if I'm using really, really thin metal that might distort, it's giving us that just a little bit of a second for it to cool off as it comes and melts it again. It's kind of a really cool process. Okay, now we're going to talk about discontinuities. Now let me tell you, GMAW-S, that's what we're working on, has inherent incomplete fusion. Okay, short circuit doesn't get as hot as many of the other transfer processes. So the problem is that we're unable to melt very good, and we have unmelted base metal. Okay, we can also have overlap. Reminds me of a belly that just sits on top of our metal. Okay, so when we don't have the base metal and the weld metal coming together very well, we create this protrusion. Remember, we want it to almost be ski jumpy when we go to the toes of our weld. All right, the other one is porosity. Okay, there are 2 types, surface or subsurface. Surface on the surface, subsurface is internal. Now, how can porosity occur? Well, most of the time it's due to gas drift. And we talked about gas drift, that our gas is blown away, right? But we can also get porosity from dirty metal. Or we can get porosity for our equipment being dirty and it being dirty, not give us enough gas. Okay, and ultimately, when we have porosity, that's the oxygen and the nitrogen that got into our weld because it wasn't shielded enough, and it's starting to bubble through. Okay, so these are really gas bubbles trying to come out. Okay, so the next one, crater crack. Let me tell you that this is probably the most common crack that I see. Usually what happens is that if you do not properly fill the end of your weld and bring it up to where it needs to be, it will create a crack because it created some stresses here. We can also have problems when we have a lot of rust or dirt or just dirty base metals. Okay, it'll also cause cracks near the end. Okay, so we want to make sure that we have filled our weld all the way when we end it. Insufficient penetration or lack of penetration. Usually this is because it's not hot enough. Okay, or we were just going so fast, or what's happening is we're letting the wire dictate where we're going and the puddle's just going willy-nilly and it's not melting. Okay, so in order for us to fix insufficient penetration, we need to turn up the heat. Okay. All right, excessive penetration. Well, this means it's too much. When we have a root opening and it is open root, excessive means too much in the root. Okay, so that would be excessive. If I have too much on the top, if I'm doing a groove weld, and in accordance with D11, the most face I can have is 1/8 of an inch. So if it exceeds 1/8 of an inch and it's really, really tall, it would be considered excessive. All right. Remember, GMAW is a lot faster than stick and a lot easier to learn. When we have groove joints for GMAW, they have thinner root faces. We can have smaller root openings and smaller groove angles, which means less metal to fill up the joint. Okay. We want to make sure that we have the proper position and angle so we can get good penetration. All right, we also want to make sure that the contact tube and gas diffuser are kept clean. Remember, bad housekeeping means that you might not have good shielding gas or your wire might get stuck. Okay, so if the wire feeder has post flow, that means the gas comes out after. You want to keep your welding gun in that area until the gas stops. Unfortunately, we don't have it. Okay, short circuit transfer with argon and CO2 is best for using for thin gauge carbon steel. A combination of high current and argon creates spray transfer. Spray transfer is very steady. It has a quiet arc and has a really defined inner cone where the metal transfer takes place. Overlap or incomplete fusion extends beyond the weld toe without fusing into the base metal. We also want to check for porosity, okay? And it's usually caused by improper shielding, gas drift. Of course, insufficient and excessive penetration are because you have failed to control your heat, whether it is too hot or too cold, whether your wire feed speed is too fast or too slow, and whether your travel speed is too fast or too slow. All right, guys, take care.